everyone, this is Arnoud, WizBiz.com, and welcome in my electronics lab, where I'd like to talk a little bit more about these breadboard kind of experimental boards that we all use. Because, like me, you might encounter a problem by attaching test leads and giving power to the boards. Most of you will recognize the problem, and perhaps I'll have a solution for that. I'd like to share my thoughts about measuring signals on a breadboard. Most of the time you have to do it like this. To connect a normal BNC, of course, is even more problematic. And if you'd like to feed in your voltage here, your power supply, you have to go like so with these clamps, and you attach that somewhere on the board, and in no time you'll have a very messy thing laying around with with test leads that are not too firmly connected to your breadboard and might get loose when you shift it around. So that is a common problem that I would like to talk about today. You might have your own solution to this. If you have your own solution, or you have a nice tip or an idea for me, just leave your comments with this video, and we can all benefit from that, I guess. So a lot of messy test leads and things laying around, and another thing is controls. You might need buttons, LEDs, switches, and all the kinds. So I found myself making things like this to represent a dip switch, or a whole board, dedicate a whole board only for push buttons. So things might get messy, and I was wondering, could we have a little bit more structure and think things over so that things might get a little bit more robust and, well, get rid of all the noise in wires and things laying around. So I came up a while ago with something like so. You might those who recognize this form factor or this kind of case, they might recognize Fisher Technique. Fisher Technique is a building block system that I use. But yeah, well, you can leave that out, but I like the form factor and the way voltages are interconnected and looped through like so with a small clip. So you can have your rectifier module here, and I also made my own module here to connect to, for instance, this breadboard. And the main thing that I'd like to show you is this. Because during my electronics study, we made a thing like this. This is almost as old as I am. That's the reason why it's a little bit yellow. But we made a small aluminum plate, folded a little bit, and inserted those banana 4mm buses and a few coaxial BNC connectors as well. This is one step up from this, so I use it. I still use this thing, but one of the drawbacks, of course, is being all the loose wires that you have to plug in to prevent short circuit and all the mess around here. And it doesn't solve your problem with the buttons and the breadboard state that you need for all your peripherals, like LEDs and all kind of stuff that you use all the time with all your experiments. So this is nice. It is, from a nostalgic point of view, it'll be still hanging around here for a long time, I hope. But in practice, I came to the conclusion that it's even better to have those connectors at the back of your breadboard. Why? Well, that's quite personal, because when I have a thing laying around here, I like to have my small, what is it called, things like this laying just beside, because there's not too much room here, as you can see. So it's even better if the test leads and probes can rest on the table and are connected at the back. So that lead, I showed you this a moment ago, to something like this, that I use all the time nowadays. The thing is, you can concatenate them and chain them together. With a small clip here, you'll connect in this case, the 9 volts going through, and you can have your own voltage regulator if you need other voltages. Of course, this is quite easy to connect also for normal test probes and test leads. If you have nice adapters like this, you can immediately connect 2 poles there to your breadboard. So what I did was these 4 are led to this yellow connector, and the other, there's no common ground here. The grounds of these BNC connectors is just led to another strip header here, so you can also use it completely independent from any common ground or a common voltage on all these connectors. So this works for me like a charm, I must say. So get rid of all those probes, and I can connect my scope directly with BNC like so. Very, very handy. And when I lay this down on my workbench, all these cables are resting nice and easily on the tabletop, so no pressure here and no detaching wires. So that's my first thing. But then I thought about all these buttons, LEDs, the PCBs or the breadboards that I constructed like this to have controls and just a few buttons, because when you use these very small breadboards, of course there is not too much estate here to facilitate at all. So wouldn't it be possible to have a test board of some kind that you can use in a modular way, just like this, and do that all for you and have that ready for you. This is what I found. This part of this module that I made here is something that I bought online and that I came across. I don't know why, but it has a matrix of 4x4 is 16 momentary push buttons. That's quite specific. I don't know if I'm gonna use that anyway, but for me it was about these 4 loose momentary buttons and the LEDs. There are 8 LEDs here that can function as a readout and substitute all kinds of LEDs that you might have on your own board. There was a little bit space left, so I added a few slide switches here. You can pick them up here, and I also needed, for another experiment, a nice clean, call it a clock pulse in TTL level, without the contact noise of these cheap monetary push buttons. So I built a small SR latch from a 7400 NAND logic gate there. What I would like to say is this solved my problems not completely. I had a few push buttons. I had my sliding switches. I had some LEDs here, which turned out to be common anodes. So all the pluses of the LEDs were interconnected. And sometimes you need a readout from an LED just the other way around, with the LED going to ground. So I switched, I guess, a few of these so that I can use these LEDs in both ways. But I just forgot which ones I have the other way around. So this was a nice step up to a final solution. So what I came up with is my own dedicated push button LED and control kind of PCB. So it turned out that way. Before we take a look at that schematics, let me show you another version of the breadboard only module that I made. This one can be connected, of course, again to a 9-volt power source by just clipping it up. And it gives 9 volts over here, but I also inserted, hope you can see, a small 7805 voltage regulator to have also the 5 volt available here. So this is nice and handy. You just plug it in, you have your voltages. It doesn't have the test lead BNCs on the back because I didn't need it at that time. So I can combine things just, well, whatever project I think what the project needs. Okay, let's take a look at the schematics of my dreamed up ideal peripheral button, push button, slide switches and all kind of stuff PCB that I dreamed about. Okay, so let's take a look at the schematics. No rocket science this time. Everything is quite easy. A on-off switch. Here we have our connector where 9 volts is coming into this board. It's either the 9 volts from a DC plug at the back of the little case, or it's the 2 metal strips on the sides of these Fischer Technique steel bedding modules. So you can switch it on. It goes through a voltage regulator making VCC 5 volts for the 7400 NAND gates that I use to build up a small SR latch. 2 of them, by the way. So each SR latch has a set and a reset push button, and I have a simple output driver for the LED to not load this output too much. So you can use it in your own circuits. So that's the SR latch kind of thing. From nostalgic point of view, there are 2 relays on there. Not everybody's cup of tea, but for my particular project, that seemed to be quite handy to have around on the board. Small relays with a small driver, and I can interconnect the input signals here with a jumper to combine these 2 single contact switching relays to one with 2 contacts. So that's about the relays. These are the small slide switches, and we have a position for a potentiometer. 4 small tactile momentary buttons, push buttons over here. And let's talk about this. This is the LED section of the board, and I did something special with it because I was not too fond of LEDs being interconnected on one side, either the plus or the ground side. I made them all floating around, and I can connect them to either the plus 5 volt power rail here or the ground rail here. So if I connect a LED with both jumpers here, it will just light. It goes on. But when I remove one of the jumpers, for instance this one, I can feed it in from a high signal with a LED in which the LED is going to be connected to ground on one side, or I can just pull it up to plus and, well, measure my open collector kind of buses and all. So in this way I try to come to a solution for LEDs to make it more practical in daily use. So you can either use them floating around just at any voltage that you might have an indicator on, or you can connect them to ground or to 5 volt. Okay, hope you like that. I do. Okay, so let's see what we get if we make a PCB out of this. Alrighty, and after I've made the schematics into a PCB design, sent it to my manufacturer and waited a while, it turned out to be something like this. I've chosen a white silkscreen finish this time because I've never ever saw that before, and well, I think it's a nice blend in with the white 3D printed cases that I had in mind. And after a while of fiddling around and soldering, you get something like this. And here we have a more close look at the back side. You can see I have misused a normal dual inline package as an SMT package. But hey, it works and it gives me more nice layout possibilities on the front of this little PCB. So I stuck some of the components to the back side. For instance, these diodes for the relays and some capacitors. But that's all inside the case and nobody will ever know. So you have your nice button layout and your LED and switches layout on the front. The relays are on here. We have the 4 LEDs with the SR latches, 2 SR latches here. Some sliding switches, this is the on-off slide. Some tactile momentary buttons over here. And of course, the possibility to plug in my own modular potentiometer system. Like this. I had a few of these potentiometers, are quite small and nice, that I thought would be nice to use on a experimental board like this, but I had to, well, 3D print a small block, a small module to make this, because once I want 45 case, and perhaps we need a little bit more, 500 case, so we can just plug that in and use that. Another brainwave that I've actually not seen before, and I think it's quite handy though, is having the possibility to jumper your LEDs on your experimental board to either plus or minus to ground. So you have your LEDs that you can use as indicators, have them completely floating around on all and to be used on all voltage levels, and not to be limited to a common anode or a common cathode array of LEDs. Okay, so let's take a look how that works out if we build that all in to a case. Well, here you have it. A little bit of hot glue did the trick of fixing it to the lid of this 3D printed case. Here we can connect our normal DC connector. There's 9 volts here. like so. Let me switch it on for the movie. Here we go. Bam. And there you have it. Two SR latches, like so, to be switched with the buttons. Okay, so here we have our LEDs, and these are now this whole array of LEDs is now wired to ground. So the moment you connect them to plus, you can use them as a readout. Of course, if we have our jumper there, that's been set to make these two relays operate at the same time. So there you have it with a normal power adapter. Of course, we can use the ancient and traditional Fisher Technique power module here as well. That will provide us with 9 volts or 9 or 10 volts. Just works the same. Here we have our SR latches, and of course we can also feed it with a more modern kind of power module that I already described in one of the other YouTube movies. Please take a look at my timeline if you're interested in a very universal power module with different voltages. I'll give it 9 volts, and let's connect the small clip connector here so you can see it also works on that one. Okay, so let's leave that on for now and just concatenate it with my breadboard module, like so. Just give that a 9-volt connection and you get a kind of modular kind of thing like this. I hope I can prove the concept here. Of course, it's quite silly because we started this all to get rid of our LEDs on breadboards, but it's just a proof of concept. And you see it works on the SR latch like so. So, well, there you have it. You can change potentiometers, you can use these LEDs. Of course, I can also use like so. Well, I hope you liked the subject of this movie, and you have some things you can use some of the things that I showed you. Okay, so this kind of concludes my proof of concept for this. Hope you like the idea and there is something for you here. If you like these ideas, just leave a comment or leave a thumbs up in the comments for this video. And well, I hope to see you with my next movie. Until then, happy hacking!